Alright, here I am, walking down the highway, risking my life to bring you good YouTube content. Alright guys, check these out. These are kind of neat little toys here. These are some, let me get in close here where you can see it. There's some LoRa modules that were sent to me by the Reyax company. Okay, and they're made for peer-to-peer. So let's look at the back of one of these. So what that means is that you can create a little network of these things, and this one can talk to this one, can talk to another one, whatever you want to do. You create a little network and they can communicate back and forth. But what these can't do is communicate with a LoRa gateway. Okay, so they're just set up for peer-to-peer, one to the other. But, you know, the idea with LoRa is that if you're sending a small amount of data, like maybe we got something set up with these and we're doing a little IoT thing, we're sending a small amount of data, then we can use LoRa to send it instead of using the Wi-Fi that's on the ESP32. And there's two reasons for that. One, the Wi-Fi on the ESP32 can use up to 300 milliamps of power while it's transmitting, which is a lot. This maxes out, I think, at 140 milliamps. So it's half the amount of power when you're transmitting. Also, the transmit time can be a lot smaller because you're just sending a tiny amounts of data here. You don't have all the overhead here that you would have with this, you know, making a Wi-Fi connection, you know, using you know, UDP or TCP. All right, so that's one thing. And then the other thing is distance, that LoRa is supposed to go further, so it gives you a bigger range of things. So what I'm going to do is get one of these minis. Here's a new mini you guys hadn't even seen yet. This is the 3 model. I'm going to get some of these minis, and we're going to set these two things up and get them talking to each other. They just use the AT commands over serial. So if we look at the, let me get this on the camera. Maybe you guys can see this. Yep. Ground. There's a UART transmit, UART receive, a reset pin, and a VDD, which is 3.3 volts on this. So this is going to communicate serially using the UART port on the ESP32. So we'll get these things set up. I wrote some software for you, and we'll get them communicating with each other, and then we'll see how much distance we can get. Just do a little test of these things. So let me get them set up. All right, let me show you my test rig. So I went down and I cut these 2 sticks here. So I've got the Reyax chips, I can't remember what they are, RYLR998. Okay, so I got the Reyax chips on the top, and to maximize transmission, I put the, you know, the antenna where it's above any of the stuff. It's the highest up piece, okay? And then we move on down, and we've got our wires connected. So red is 3 volts, the brown is the ground, the orange is the reset, the yellow is going to be the receiving data on the UART, the TX, the green is the, no, I got those backwards because it's the other way on the ESP32. Okay, so the yellow is okay, starting over on the wires. The red is the 3.3. The brown is ground. The orange is the reset. The reset is held low, so we just have to give a positive pulse for 100 milliseconds to reset. This is the receive. This is the RX for this, and this is the TX for this. Okay, and then when we go down to the ESP32, I got these marked as, this is the bounce and this is the send. BS, don't read that the wrong way. Okay, so So this one's gonna send a signal. This one's gonna pick it up and bounce it back, send it back to this one, the same signal back. And then this one checks to make sure it's getting the right signal, and then it will flash when it gets the right signal. So actually they're running right now, okay? So this one sends, this one gets it, it flashes when it bounces. This one gets it, it flashes when it checks and knows that it's correct. Same signal back. All right, so this is the ESP32. So up there, we're just bringing this down and we're picking up a ground here and a 3.3 volt right there. And then we're coming down here and this is our reset. Pin 19 or 18, 17 is the transmit, and 16 is the receive on the UART here. And then this is the programming UART, which is not going anywhere. Okay, and then we got a ground coming off down here. And then so these are our programming UARTs, which we're not using at the moment. And then here's this is actually 4.2 in down from this lithium. Come on, focus. From this lithium battery. Okay, so that's our test setup. Sent from here, bounces from here, flashes when it sends it back, and then this flashes when it's verified that it got back the same message. All right, so this is a mini ESP32 mini V1. This is the V2. I didn't use the V3. Okay, so that's our setup, and that's what we're going to test and see how far apart we can get with these things, sending data. All right, let's see. I think we'll look at the software now and see what it actually looks like sending back and forth. Okay, as with all the software, everything's up here on Clayton's PCB shop on GitLab. So there's the address right there, Deuter 1966. Okay, so if you go down to MicroPython, and there it is right there, the RYLR998. That's very difficult for me to say. Alright, so whatever you see here is exactly what we're going over right here. Okay, so the place we want to start is with the docks. So let me get this where you can see it. And this is the info, or the, I don't know, I guess it's the data sheet. Gives you some basic stuff about it. Here's your pinouts, okay, little timing stuff, and here's the important thing, specs. So 3.3 volts, don't over voltage it like people tend to do with 5 volts. It's 3.3. Alright, that's important. And then here's the other interesting thing is 140 milliamps at 22 decibels. So that is when it's at maximum transmission power, it can pull 140. So I've seen the ESP32 Wi-Fi go as high as 400, spiking up to 400 on Kevin DeRoss' channel, and then 3 to 200 milliamps kind of at a steady rate while it's transmitting. So this is a lot less, up to 50% less, I would say, when it's transmitting. And then here is the receiving mode is pretty low. Okay, so those are the important things right there, or the things that I'm interested in. But that's the data sheet. I did notice, that this antenna, there's a lot of leverage on that little solder joint right there. And mine was actually broken when I received it, and I had to resolder it and get that back on there because something had just pushed on this and it had snapped it off there. Okay, so that's the data sheet. And the more interesting one is this, which is the AT command guide. So this is for our device we're using. It uses these AT commands, and you'll see this a lot with cell modules and that sort of stuff. It's just a UART, serial way to communicate with modules. So you give it an AT command, the AT, and then some kind of command like address, and then you usually follow it with a 1013, a new RN, return in a new line. And that indicates that a command has been sent, and then you'll get some data back, and it'll be followed by a 1013 new line, or what is it, DA, hex DA. Anyway, so that's how it works, and they give you this nice little rundown of how to do it, and then here's where they're telling you to always follow it with that. Here's all the commands that they have in there. So basic AT, resets, setting the mode where you can put in sleep mode. Here's your baud rates. We're just using the default. That's for the serial communication. There's parameters for the LoRa transmission. There's bandwidth. Of course, we're using this bandwidth because we're in the United States. You'd have to set your own. Now each device has to have an address on the local network that it's creating, and then there also has to be a network ID. So you're creating, this is a peer-to-peer setup, so you're creating this little network of LoRa devices. You give your network an ID, and then you set each module with an address, and then everybody can communicate and talk back and forth to any module that is in the same network. Okay, we're using network 18 as the default. We're using all defaults for this testing. Here's your power. You can go up to 22 as the maximum, which is twice as much as 11.
These go to 11.
Here's the send command. It's a little, you gotta put an address, where is it going to on the network. You got to put a payload length, and the data has to be in bytes and all that sort of stuff. Guess what? I got software for that. Here's the receive thing. I got software parsing that out. Here's the queries that you can make. You can do a factory reset. Okay, so that's all the stuff that you. Oh, and then here's a bunch of error codes, but I implemented that in software too. So you need to look through this so you know what it does, right? But because it's what I do, I made code for it. So here's the device. Hold on, let me get this visible for you guys. Right there. Right there. Okay. So basically, here's the class for this module. Here are the important variables. What address is it? What is the network ID, and then how much power are you transmitting? And then these other, here's the pins we're using. Here's pin 18 is our reset pin that we're using on the ESP32, and 16 and 17 are UART pins, and these are the UART pins that are actually assigned in the ESP32 for the hardware UART. There's our frequency, and these are the parameters. These are all defaults. Okay. That's the way it comes set up, but when you instantiate it right here, when it inits, you can give it your network ID, your address, and your power value right there, and it'll set those up. So basically, I also encoded these. These are all your errors. So anyway, basically when you instantiate this, it's going to fix these variables for you, do a hard reset of the device using the pin 18 or whatever you assign. And then it sets up your port, your UART port, flushes the UART port, asks if the device is okay over the UART, and then it goes through the device setup process using these variables up here, or the ones that you put in when you instantiated it there. Now if you instantiate it and then change these variables, then you need to call this. Just call update, and it will redo the init, set everything back up again. Alright, flush. This is all UART stuff, the buffer and all that, read lines. This parses the plus RCV command. It's one of the AT receive commands. Parses that for you and gives you a little dictionary of all the stuff. Address that sent it, the data length, the data, and these are power factors of how good the signal was. Here's your send command. So instead of you having to calculate the length and convert everything to bytes and all that sort of stuff, this just does it for you. All right, so it just works it out for you. This is a nice command, sent. The device is storing the last sent data, so you can use this command and get back the address, the length, and the data that you sent the last time. And we're using that in the code, you'll see, for comparing. Wait for it is when you send an AT command, you're going to get a command back. So this just helps you wait for a command that starts with whatever you tell it. There's a timeout, and then when it gets that command, starts with that, it'll give it back to you. Alright, here's hard reset. That's using the pin. I told you wrong earlier that the reset happens at low, so that pin has to be pulled low right there for 100 milliseconds, and that will cause the reset. And then you got to pull it back high, and then you can disengage it because it has a pull up on it. Okay, so that's what that is. There's also a software reset. So you send this reset command, it's a dear AT command, and then you wait for it to tell you that it's ready. Ask if it's okay, put it to sleep. Okay, you can go into sleep mode, and so that saves power. So let's say you send a message, you get some stuff back, you're good to go. You're going to wait for a while before you send a message again, and you can put it into sleep mode. But you can't, when you put it into sleep mode, it ignores everything, right? So you have to wake it back up before you can get data or send data on the network. And then here's the whole setup deal. And then this is a nice one that you can call, and it just goes through all of the commands and parameters and all that. It queries the device, gets it all back for you, and returns it to you in a dictionary, or it'll print it out for you, just so you know what's going on. Anyway, so that's just a little nice things. Or they're nice for me. You might care less. Alright, so let's look at main, and I'll show you basically how we're running these two things. So remember, we have one that is a sender, and it's sending a message. I can't get this thing to, what the heck, there we go. Okay, so we have one that's a sender, it's sending a message, and then we have one that is the bouncer, and it's just waiting to get a message. When it gets the message, it sends it back. Alright, so the last time I loaded this as main.py, I was using the send option. Okay, so if I commented this out and uncommented that out, then it would be using the bounce option for the other one. Okay. Alright, so here's a class for the bouncer, and then here is actually a function that you can call that sets it up for you. So it just instantiates the bouncer and tells it to bounce. And I have the bouncer by default using address 1 on network 18, full power. And so down here, the sender, I have by default, the sender's on 2, full power on network 18, just for ease of doing it. So let's look at what the bouncer's doing. So when you init, you can give it all this other stuff, but I'm just using the way I set it up as default. So it's instantiating the device as self.LoRa, and then what it's doing is just going into a loop. It's reading a line using this read line function. Excuse me. If there's not a line, or if the line is an empty string, then it's going to wait 1/10 of a second and do it again. Okay, but if the line is not, then it's going to turn on the LED. So the LED is on pin 2, so I'm just setting pin 2 high. It is going to print a space, print a line, and then it's going to tell you what it read. And if the line is a receive message, that's the AT indicator, a receive message, then it's going to parse that receive message right here. So it's using the LoRa class we instantiated. It's parsing that, it's getting a little dictionary back of all the pieces, and then it just prints what it sent. So here's the parse data, so the address, the data, and then it's sending that data back, address and data. sending it right back. Okay, so that's really all it's doing. Oh, and then it turns here's where it turns the LED off. All right, so when you call that on the one ESP32, the bouncer one, it's just waiting for a message. If it gets a message, it prints it out and it sends it back. If it's a received message, so it always sends it back to the same address that it got it from, and it sends back exactly the same data. Okay, so that's what the bouncer's doing. So one of these ESP32s is loaded with this bouncer software, and it's set up to run. See, the run is down here, so once it loads, it runs the run, and it's running bounce. Okay, the other one is set up like this, so when run runs, it runs send instead of bounce. So let's look at what sending is doing. Okay, so same thing, instantiates it using address 2 as the default, and then it's just looping. Okay, so it does a loop. It prints out what loop it's on, and then the first thing it does is it reads all of the messages that it's received, and it prints line in what the message was, and if it was a received message, then it's parsing it right here, parses that received message, and then it's asking what was the last message that I sent right here. So it's getting that last message sent back, and that's a list, and so I'll go ahead and put the receive into a list of address, data length, data. That's going to be the same thing that comes back in this one. So if these two are the same, well, I'm printing them right here. And then I'm saying if those two are the same, meaning the last message that I got matches the last message that I sent, then I'm saying printing match equals true, and I'm turning the LED on for 1/10 of a second, right? So that's just saying, okay, so, okay, and then the last thing that it does is it sends a new message. Okay, so it says hello from loops, or hello from loop, whatever the loop count is, and it prints that it sent a message. So this message will get sent, then it'll wait for a second, 100 milliseconds a second, and then, or 1,000 milliseconds. No, milli. 1,000 milliseconds is a second. So it sends this message, it waits, and then it looks for what it received back, and it tries to match the one that it last sent with the one that it got. And if it's good, it blinks the light. So that verifies that the message went out and that it came back and that it was the same, and it's good. Okay, and this is just the function that calls it. So let's look at what this looks like. So over here on this side is the bouncer. So you can see it's, let me scroll this up where it'll, I don't know if that'll stop. Yeah. Okay, so line in, so in this case, so line in, it received from address 2, 21 bytes of data, hello from loop 2085. And then it's just saying I'm sending back to address 2, hello for loop 2085, and it's sent true. Okay, so that's all that it's doing. It's getting a message in, sending it out. These other things are, you know, the strength of the signal and that sort of thing. So that's the bouncer. That's what it's doing. And then here is the here's the sender. So in this case, so here's the loop number. I got a line in from address 1. 21 bytes of data, hello from loop 2126. So here, and then this was the last thing that I sent, and it matches what I received. It says match, okay, it matches. And then it's sending a new one, 2127. Okay, so that's what it looks like if you're actually hooked up to the UART of the ESP32. So that's what's happening back and forth. This light on this side, the light is coming on while it's sending, or while it's reading the line and sending. And then on this side, the light comes on when everything is okay. Okay, so the only thing we got to do now is go outside somewhere and see how far these things will transmit. So I've got my batteries charged to 100% right now, and we'll go find a place to test this out. Alright, here I am, walking down the highway, risking my life to bring you good YouTube content. Alright, so back there behind me is my truck with the bouncer. And right here is the sender. I've got a glove over because it's raining, so I'm giving the finger to everyone. Anyway, so do you see? Let me see if you can. I don't know if you can see that. Yep, it's flashing. Okay, so it's flashing. So here we are. So behind me is the bouncer. Going this way is certain death. No, it's 2 miles of straight open road. All right, so let's just walk down here. And I'm still getting the signal. Here, I'll put this where you guys can see it. And we'll just see how far we can go with this thing. Alright, I've lost the signal. Oh, nope. Nope. It's far and few between, though. See if you guys can even see it. Let's see if I can get one. I'm looking. Nope, let me put it up higher. Nope. Alright, so now I'm gonna walk back to the truck. So I'd say we're probably 500 meters away. Oh wait, I'm getting it again. Alright, there it is. So I'm getting it pretty strong right now. So let's see how far I can go. Okay, I'm getting close to calling it. I'm getting a signal now, but it's only every, you know, I get a few flashes, solid flashes, so it would be usable in a way, but I'm getting a few solid flashes, then it's like right now it's not doing anything. If I put it up really high, no, I'm not getting anything. Oh, now I'm getting something. Okay, I got it solid right there. Raising it up really high. Nope. Yep. Okay. Maybe we can go further. Alright. I don't know if you can see that flashing, but I got it up. Oh, now it's stopped. Anyway, I think this is the extent of it right here. So I'm going to, I think I'm going to call it right here. So it's getting dark anyway. I don't know how far I am. I'm guessing I'm 400 meters away, which is pretty good. I mean, that's past what Wi-Fi is going to do easily. So let's see. I'm going to get out my phone and mark my position. Yeah, even just this much more, I'm out of the signal range. So I'm going to get out my phone, mark my position, and then we're going to call it right here. All right, now we're back to about half the distance, and we're getting it pretty. It's really consistent now. When I was further out, 400 or 500 meters, I would get it, but I had to be in just the right place, you know. So there were a lot of things that might affect it. Road signs in the way. I don't know. Terrain, magnetism of the earth, other mystical powers seem to be affecting it. So, all right. Well, this is pretty good. Let's go back. I'm going to look on Google and get the exact distances that I went. All right, back at the truck. I'm not sure you can see it. Well, yeah, you probably can. Okay, so there was that's the bouncer sitting on this tripod. So it was pretty elevated up there. And look at that. That's a full moon. We're supposed to have a lunar eclipse later tonight. I think it starts about 10 o'clock. All right, my truck was parked about well, it was just right on this corner, so we'll go right there. And then I walked to about where this was. Hadn't gotten to the end of that rail yet, so this is where I recorded on my phone. So to right there. So that gives us 594 meters, so 600 meters. So this was where I got my last signal, was 600 meters away from where the truck was. So all things considered, that's way further than Wi-Fi is going to go. And you were using those little tiny antennas. So if you had a better, like a high gain antenna, even better. Now it was a bit temperamental, so it was about here, so maybe about 300, well, halfway would be 300 meters. I know I was getting good reception at the halfway point. So 300 meters, that's not bad for those little devices. So all in all, I'm pretty pleased with it. I mean, you would have to make sure you had your antennas in the right place, there wasn't too many obstructions in the middle, and that sort of thing. But overall, that's a lot farther than I thought it was going to go with those tiny antennas. So very cool. All right, I'm done.